So I've got a hillside property that has some fairly steep gradients in it that I've been mowing with a weed whacker and more recently a vertical shaft wheeled lawnmower. And it's a pretty tough job at the best of times, so I was looking for a machine that might be more suitable for actually mowing that lawn. In my research I came across a product called the Phoenix Hover Mower, which is made and sold in New Zealand by a company called Small Engines Direct. So I rang Small Engines Direct and talked to a salesman on the phone and detailed exactly what I needed the mower for. Now, I made a list of points to query the salesman about, ranging from the height of the lawn that can be mowed with the machine, through to what the machine can actually tolerate in terms of stones and other sort of woody organic material, and we had a conversation at length about these topics, and the conclusion of the conversation was that my requirements fell well within what the machine is designed and marketed to be able to do. So I received it 3 days ago. I made an order, received it 3 days ago, and opened the box, read the manual, filled it with gas, and straight off the bat, there was actually a leak in the seam of the fuel tank. Now it's neither here nor there. I mean, it's a quality control issue by the engine manufacturer, which is actually a Chinese company. I cleaned it and applied some suitable sealant, and it sealed it up, and I got on with the job. So I managed to get about 20 square metres done before I saw that the blade had actually protruded out the side of the shell. I shut it off, removed the spark plug and flipped it over to see that actually there's been a lot of rubbing by the blades on the underside of the shell. Now, it's important to note that this shell is actually HDPE, which is a really tough but reasonably soft material, plastic, that under small loads can quite easily twist and move. So one example of this is where the handles join the shell are on opposite points across from the motor. There's no bracing or anything between the motor mount points and these handles. So as the machine has been operated, a small amount of torsion has actually caused these blades to ride around the shell. Now we can see here that up the top there's actually a very small amount of tolerance. If we can get a good shot, there's only about 8 to 10 mil of tolerance between the end of the blade and the shell. So it takes me very little force. I would say that would be less than 500 grams of force to actually have the blade make contact with the shell. Now, as the blade rotates, it actually comes into the space here where there's more like 20 to 30 mil of space, and as it comes back round into the area where it has a very small amount of space, it's been making contact, and in some cases has actually ridden into the shell and actually made a cut right through to the outside. So it's not necessarily a wear issue, although after 20 square metres you would expect that there would be by no means this much wear. But it's in many regards is a design fault with a combination of tolerance between blade and shell, material that the shell is made out of, and its flexibility, and ultimately the power and high revving sort of nature of this two-stroke engine. So one other consideration is worth making with this machine. You've got this large impeller or disc here, which when it's spinning at high speed forms sort of like a gyroscopic effect, and I sort of noted this after starting it up and sort of just having a bit of an experiment with what might have been causing this. If the shell is moved relatively quickly, in its relationship with the motor, which is held in position by the gyroscopic effect of this this plate, you actually get contact just in free air with no actual pressure or no contact on the blades or disc. So that is illustrative of the design sort of failings in this particular machine. And yeah, so I'll be sending it back. Looking forward to the refund, and best of luck with refining the design.